All right, that's enough of that. Okay, so today, we got a lot to do. Probably shouldn't have let that one go for very long. Today we're talking about surface area and volume of prisms and cylinders. All right, we get into our 3D shapes. So those are our goals for today. Okay, let's talk about prisms first. So there are different types of prisms out there, and different types of 3D shapes. When we talk about prisms first, prisms are always defined by their base. Okay, every prism is going to have lateral edges that are rectangles, but prisms are defined by their base. And what do I mean by that? Well, this right here would be a triangular prism. Why? Because its base is a triangle. Now, you're thinking to yourself, but the prism isn't standing on the triangle. Well, the base is the unique shape within the prism. Okay? So, what I mean by that is I could have a prism that was a hexagonal base, it has a hexagon as a base, and the unique shape is the hexagon. You could have a prism whose base is a pentagon or something like that, a triangle, obviously, a rectangle, but a rectangular prism just looks like whatever. I mean, that just looks like, you know what I mean. Rectangular prism, it's hard to find the bases because they're all rectangles. Right? All the faces are rectangles. Obviously, there's a special one out there called the cube. All right, we've heard of a cube before. Pyramids, cones, and cylinders. Cylinders we'll talk about later today. Pyramids and cones we'll talk about in our next lesson. All right, total surface area. So if I want to think about the total surface area of a prism, okay, what I can do is I can unpack every single face of the prism, okay? So if I think about a box of Kleenex here, okay, box of Kleenex, all right? Now I could think here to find the total surface area, I could find the area of every single face, okay, of my box, all right, and unpack it and add that together. That's a possible way. All right. The other possible way is to find the perimeter of the base. So here we go. So the total surface area, or TSA. So total surface area, or just surface area, is the perimeter of the base times the height of my shape plus 2 times the area of the base. Very important that you understand this capital B is the area of the base. Okay, because there will be lowercase b's, and that's kind of confusing. And this is the perimeter of the actual base. All right. Well, this is just the height of the shape. Well, if I look at this first one, what shape is unique here? Well, you'll see that I have 3 rectangles and 2 triangles. That means our base is the holy buckets. Our base is the triangle. So what I like to do, the first thing I like to do is to redraw my base. So here's my base. I'm going to redraw it. Maybe I could do a better job of that. Okay. All right, let's try it one more time. That's okay. That's better. I know this is 3 and this is 8. And these are right angles. Okay. So I want to find the perimeter. Well, the perimeter of my base, this is an equilateral triangle here. So I know my perimeter is 24. Now it's hard to see down here, but there's supposed to be a little tick mark, and I apologize for that. Okay. The perimeter of my base is 24. 8 plus 8 plus 8 gives me 24. The area of my base, so my capital B, is to find the area of a triangle, do base times height divided by 2. So 8 times 3 over 2, which gives me 12. The height of my shape is the leftover number. What haven't I used yet? I used this, I use all of these sides here. I haven't used the 12. So the height of the shape is 12. Okay, it's that leftover number on the outside. So if I want to find the total surface area of this shape, I would do 24 times the height of 12 plus 2 times 12. And this 12 is the height, and this, the area of the base, is this 12 here, and this is the perimeter. Okay. Let's get the calculator out for that one. 24 times 12 plus 24. You should get, I got 312. And this is still square units, even though it's surface area. All right. Volume is a little bit different. The biggest difference in volume is that we're measuring in cubic units. Okay, in cubic units. All right. I want to think about volume as the amount of water it takes to fill a box, or amount of water it takes to fill something up. Okay, so we think about that in cubic units. Okay, and I could show you the example of why it's like when I do leg times width times height, I'm doing inches times inches, so it's inches cubed. Okay, the volume of the prism is capital B times H. Remember, B is still the area of the base, and H is the height. All right, so now if I want to find the volume of this shape, okay, I want to decide, okay, which face should I make my base? All right, which one should I call my base? Well, if it's a rectangular prism, guys, it doesn't matter. The only time it matters is if it's a unique shape. Like here, the base matters because the unique shape is a triangle. Here, it doesn't because every face is the same. Faces are, this is a face here, this blue is a face, the red is a face, okay? These are edges, all right, where the faces meet. Like if we think about like a box, this is the edge, this is the face, okay? The face is the two-dimensional shape. So I am going to call the base this blue part here, all right? The top, all right? We'll call it purple. Let's call it purple. Let's make it purple. Okay, so I'm going to call the base the purple face, okay, because that's where it's sitting on. So to find the volume, it's the area of the base times the height. Well, let's find the area of the base, a capital B. How do I find that? 7 times 14. Well, I use the 7, I use the 14. What's left over? The 6. Uh-oh. Oh, boy. So let's find the volume of the entire thing. Well, the volume will be the area of our base, 7 times 14, which is 98, times 6. Now, some of you may recognize that all I did was multiply 7 times 14 times 6. When you have a rectangular prism, to find the volume, it's really leg times width times height. Not all of our prisms would be rectangular, so I like to get in the practice of finding the area of the base first, especially when we deal with the surface area. All right, we're cruising. Let's talk total surface area of a cylinder. Cylinder and prisms are related because in a cylinder, okay, the bases are going to be circles. All right, that's how they are related. So if I want to find the total surface area of a circle, or excuse me, of a cylinder, total surface area or surface area, it's going to be 2 pi r h plus 2 pi r squared. Well, if you recognize from the last one, it was the perimeter times the height plus the area, 2 times the area of the base, right? That was from a prism. Well, the perimeter of a circle is the circumference. To find the circumference is 2 pi rh. The area of our base, well, our base is a circle. To find the area of a circle, I do pi r squared. So that is where this comes from. That's how they're related, except now we just use our properties of circles. Okay, this is how you would find surface area of a circle or a cylinder. Wow. So let's do a soup can. Whoa, a soup can? I feel like I see these at grocery stores. Hey, you do? Oh, yes. Yes, I do. So I guess you could go to a grocery store, grab a soup can, find the total surface area of the soup can. That's pretty sick. Why don't we try it? Maybe I'll do that today when I go to the grocery store. So here we go. 2 pi. My radius is 2 because this is the diameter. The height is right here is 6 plus 2 pi, again, radius is 2 squared. So I have 2 times 2, which is 4 times 6 gives me 24 pi, plus 2 squared is 4 times 2 gives me 8 pi. Write your answer in terms of pi unless it tells you to use round to a nearest decimal. So you should get 32 pi inches squared. So if you're at the grocery store and you're like, hey, what's the total surface area of this can? Well, let me tell you something right now. It's 32 pi inches squared. Now, if someone there is like, what do you mean pi? I don't mean like pi in terms of pi. I mean pi like math. What? All right, so so if we want to find the volume of a cylinder. Volume of a cylinder closely related to the volume of the prism. Volume of the prism was the area of the base times the height. So the volume of the cylinder is going to be the area of the base times the height. Except remember, our base is a circle, pi r squared h. I can do this one, except the radius here will be 20, since this applies to the diameter, and the height would be 10. Okay. Let's look at this one. I'm gonna read this to you. Billy likes to drink soda. Wow. He likes it so much that he wants to try to drink it out of a glass instead of a can. Wow. He's not sure if he can pour all of the can into the glass without it overflowing, or if he can fit more than one can in a glass. Such a common problem. Can you help him out? We're gonna try. The can has a radius of 3 and a height of 5. The glass is a radius of 5 and a height of 7. So how would I determine this? How would I determine how much liquid is in the can versus how much liquid can fit in the glass? Well, so happy you asked. We're going to have to find two things. The volume of the can and the volume of the glass. This is a common problem I deal with every day. Okay, so why don't you go ahead and pause the video here and try to find the volume of the can and the volume of the glass. And then see if you can come to a conclusion. All right, so I got volume of my can, I got 45 pi. Remember, I do pi r squared, 3 squared first, so 9 times 5. 5 squared first, so 25 times 7. All right, so to find the volume, to find how many of these can fit into that, I actually multiplied the pi out so I could divide these numbers pretty easily. I'm going to divide the volume of the glass by the volume of the can. Okay, so I did 549.78 over 141.37, and I got about 3.88. So I would say roughly 3 to 4. 3 to 4 cans. That's a lot of soda. Why did I put apostrophe yes? Not sure. Unclear about that one. That's a lot of soda. All right. So, let's talk about calculator errors. I tried to plug this in my calculator. 175 divided by 45 pi with the pi's on it like that. If you're going to do that, make sure you put 175 pi in parentheses and 45 pi in parentheses as well. All right. Then otherwise you'll get a calculator error with the order of operations there. Okay. So I would make sure there's parentheses around that. All right. That's it for today. Billy likes to drink soda. If you know what movie this comes from, Billy likes to drink soda. Props. Okay, it's an old school movie by an actor that has made some movies recently. Most of his movies are on Netflix, but he made one that was pretty intense. Not intense, but a serious movie that came out recently. I don't want to give too much away. Yeah. Adios. Have a good rest of your day.